Hi everyone, welcome to my video for Mechatronic project Millies Flying Fish. Doing the inertial measurement unit calibration phase, so come on over here. So we're going to move our fish out to 90 degrees. We're going to try and set this up first because I've been struggling to get it right. So I've got to hold that there very fixed and very steady. Okay, so we've got our calibration running now. So we've got that running, holding, there we go. Calibration is out and we're off and racing around about that 90 degrees, 99.99999. And we're changing a little bit there. Yeah, it's pretty reasonable though. So you can see our intervals here. They're all about 5, 6, 7, getting up there. So getting lots of nice samples pretty quickly. Okay, so let's see how we go. How do we do this time? We're sitting around 90. And you look over here on the unit, you can see we're hovering right over that 90. Which is exactly what we want to see. Going to move over to 100 now. What are we on the... See, we're sitting there right around 100 degrees on the program. So as you see, the most important part is the calibration phase. You get that right, then it works really nicely. So I'm going to go out to 70 degrees now. And we're on 70 degrees here too. Yeah. Alright, come back over here, Josie. I'm going to swing it out fast, and then you can see it on the computer here. So you see how we went really quickly. We went from 70 all the way quickly through to 180. Okay, so we're around at that 180 degrees there, so that's it there. So it's working really good. I ended up having to upgrade the speed. I changed the gyro scale range up to 500 samples. Yeah, works much better. The 250 was just too slow. I was getting way too much drift in my scales and my response time. And then I also changed my loop time from 20 microseconds to 5 microseconds. It made a big difference. So that's the flying fish. That's the calibration. So I'll go through the program quickly over here. How are we going for time? We're at 2 minutes. Yep, that's good. Well, it's about a bit over 2 minutes, but we got up to 5. I'm not allowed to go over 5. So we start with the program, we include the libraries, do some declarations, initialize our starting Y angle to 90 degrees. That's just what I've picked as my 0 zone. Something nice and easy for me. Start our serial comms, we're using a baud rate of 38400. Send that little bit of notification to the IMU to tell them we're going to start the calibration. Initialize it, and then we're going to set it up with our ranges there. So then it goes through, it checks, is it talking to the Arduino, is it connected? Yes. We keep going through. No, we'd retry. We'll keep going through, initialize, and then we do another calibration hold. We do here, now we go for our 500 samples. We keep looping through till we get 500 samples. This calculates our stationary bias values, so that's part of the initial calibration in the first setup, and then it displays those values after it finishes that step. So now we start our time in millis and microseconds, and then we end that time. This records our very first time elapsed for our integration cycle calculation. Set up our time calculations for the integration. Then we start the next time here for the start of the loop. And that time will keep running until it comes all the way back up to this end time here. So as part of the loop, we read all 6 raw sensor data. Then we go to calibrate all raw data. And then we go to the integration phase. So we integrate that data and update the fish angle. And then at 300 milliseconds, no, microseconds, it'll print out an updated display of what you're seeing over on the serial monitor, and after it finishes that, and then it will run back after 5 seconds. I've got this here saying 20 will update this back to the start of the program. Well, that's it for now. Thanks for listening. Hope you enjoyed that video, and until next time, thanks again for watching.